In this video, I want to do a brief overview of memory leaks, kind of give you a rough idea of what causes them, because if you play games often or you go and read through community forums for just random games, you might come across something where people, especially in early access or betas of the game, will say, hey, there's a memory leak or something like that. Well, what is that? So a memory leak is when let's say you take up a space in memory and you never free it. So in my pointer video, I always use the cubby example. So let's say here, this line 13, what we're doing is we are taking up a cubby. So we're taking up this space right here. So we're filling it. Well, this is going to be a loop. So it's going to run again and eventually come back and create another one. So we're just going to take up another space. Then we're going to do it again and again and again until there's no more, eventually I'll get there, spaces left. Now, what can you do to kind of prevent this? Well, obviously you could free up that memory. So with a raw pointer, all we have to do in C++ is just call delete. So we're going to do delete waste. And then whenever we run line 13, we're going to fill up a space in memory. Then we're going to hit line 14 and free it back up so that it can be used again. So we're not taking up any more spaces in the cubby when we don't need to. Now there are some dangers to using raw pointers. So for example, if we have it like this, well, we have to make sure that eventually we will go through and free up our pointer. So we can't just do, delete waste because it's out of scope. It can't access waste, or better yet, it's saying it's unidentified because the only place that knows what waste is inside of this if statement. So we can't do anything about that. So to kind of give you a visual representation of what it's actually doing, let's go ahead and launch the program. I have it set up so it'll create a bunch of memory, we're going to create our memory leak when we hold down F1, and then we can press F2 and see how much we have created. So I hold down F1, and as you can see, we started out with 1 megabyte used, going up 26, 35, and it just keeps going up and up and up. So I let off, press F2. We have created 4,925,193 integers in memory, or better yet, pointers. So each one of those is 4 bytes. So if we load up our calculator, we can do 4925193 times that by 4. And we have created 19,700,772 bytes in memory. That is literally doing nothing and doesn't get freed until the program closes because we cannot free it. So that's an example of us taking up each one of these cubbies without freeing it, because eventually you're going to run out. So that's where delete comes in. So if I do the exact same thing and just do delete waste like before, go ahead and run it. You can see we're using 1 megabyte. I hold down F1 and it still stays at 1 megabyte used. Press F2 and we created 2,527,000, blah, blah, blah. You get the idea. So we're freeing up that memory. Now this can be tricky for games especially because pretty much everything you use is going to be a pointer. So you're going to have your character. Your character is most likely a pointer. Well, guess what's going to be in your character? Probably a gun. Well, that gun's going to be its own class, and it's most likely going to be a pointer to that class. And what's your gun going to have? Well, it's going to have magazines or clips depending on what you're using. Well, guess what those are going to be? Most likely pointers. So you're going to have just a train of pointers that pretty much could have several layers deep. And you have to make sure when one gets destroyed, you go through and remove the rest of those, freeing up that memory. So let's say you have projectiles. Like when you shoot your gun in the game, you spawn a projectile. Well, that projectile takes up space in memory. What if that projectile never gets destroyed? Well, then you're going to keep creating more and more space, just wasting memory each time. So there's kind of like, you always have to make sure you destroy your pointers or delete them. I use the word destroy because in Real Engine you call destroy on an actor. That's just kind of habit at this point. And the other way you can kind of resolve this as well, just in normal using standard C++, is you can use smart pointers. So if you recall, when I say once waste is out of scope, we can't do anything with it, so we can't delete it. Well, if we switch this over to use a smart pointer, so standard library, we're going to use a unique pointer of the type integer. What we can do, well, let me rephrase that. What it can do is when waste becomes out of scope, such as we get past this line right here, it's going to clear itself up. So if I go ahead and run this again with the smart pointer, we're using 1 megabyte. I hold down F1 and we're still using 1 megabyte. So I press F2. We've created 3,465,000 and again, blah, blah, blah. So we've created a lot of copies. Well, let me rephrase that. A lot of them, but they're getting destroyed automatically because they're going out of scope. So that goes the same for all the others. So we have the weak pointer and we have the, we already did the unique. It was the, I'm being brain dead, shared pointer. They're all going to work the same way. So anytime they come out of scope, they clean themselves up for you. So eventually I'm going to have a video just for smart pointers. There's not really a whole lot to cover with them. There's only 3, and they all have their own purposes, and same thing goes for raw pointers. So for something like this, where we have just a while loop, where you are constantly just creating pointers, what I would do, I would stick with a raw pointer, just because there's no concern of what's going to be going on with it. You just have to make sure you destroy it yourself, obviously, but you don't have any of the overhead that comes with smart pointers. Even though that overhead is extremely small, there's no need to add any more onto it when you could just do something as simple as this, but obviously that's depending on the case. So your situation is going to be different. Anyhow, that's pretty much wraps up kind of my point. Hopefully I gave you a rough idea of what memory leaks are and kind of ways to take care of them. But obviously, if it's so simple, why would anyone have memory leaks in the first place? Or why wouldn't they be able to just fix it immediately? Well, because it gets a little tricky. Because like I said, in regards to game development, you can get pointers that are several layers deep, and you got to kind of track down and trace what is not getting freed up and when is it supposed to get freed up, but it's not, kind of thing. Anyways, that's going to be it for this video. If you like what I'm doing and you want to help support me, you can find a link to my Patreon down in the description below, where I have a team deathmatch series built in Unreal Engine with C++ just for my patrons. Obviously, that's kind of why I keep referring to Unreal Engine, because it's just habit. And if you have any questions or anything like that, feel free to join my Discord down below as well, and I will see you in the next video.